Good day, learners. So today we're going to study about the earthquake epicenter. So this is for quarter 1, week 2. So the shaking and vibration of the surface of the earth resulting from underground movement along a fault plane or from volcanic activity is known as earthquake. We also have a break in the earth's crust, and along the break, significant movement has taken place. This is known as fault. The place where the fault begins to slip, where the first movement occurs, is known as the focus. Focus is also known as the hypocenter. The spot directly above the focus on the surface of the earth is known as the epicenter. A wave produced by a sudden push from an underwater fault is tsunami. So tsunami is a Japanese word or term for harbor waves. The release of energy calculated by scientists is known as magnitude. The observed effects of earthquake in different places is known as intensity. Pacific Ring of Fire is an area of frequent earthquake and volcanic activity around the Pacific Ocean. Philippines is located in this region. Last week, we also studied that the entire lithosphere of the Earth is broken into numerous segments which we called plates. And we have this theory of plate tectonics stating that the Earth's crust and part of the upper mantle are broken into sections called plates, which are moving above a plastic-like layer of the mantle, which is called the asthenosphere. Now, what will you expect to happen when the pressure plates move? Obviously, we expect an earthquake. So again, earthquake is a vibration of the Earth produced by a rapid release of energy in the Earth's crust, and this energy radiates in all directions from the focus in a form of waves called seismic waves. So we have different types of seismic wave. So the two main types of seismic waves are the body waves and surface waves. The body waves has two types as well. So we have the P wave and the S waves. Surface waves is also classified into two, which are the Rayleigh wave and the log wave. So the P waves. So as you can see in the figure, you have here the P waves. So it is the first to arrive in a seismographic station. While S waves, or also known as secondary waves, is the second to arrive in a seismographic station. So primary waves are longitudinal and compression, while the secondary waves are transverse or shear. P waves can travel in all states of matter, including solid, liquid, and gas, while S waves can only travel through solids. So, P waves are longitudinal seismic body waves with a great velocity through the ground. With that, P waves is the fastest among all the seismic waves. The direction of the particle is parallel to the direction of the wave motion. S waves, on the other hand, are transverse waves. So they are moving side to side from the source to the outer layer of the Earth. The direction of the particles is perpendicular to the direction of the wave motion. S waves travel slower than P waves. So it travels 40% slower than P waves, ranging from 900 meters per second to 4,500 meters per second. So Rayleigh wave are waves characterized with a rolling up and down motion with an elliptical and reversing particle motion, confined to the vertical plane in the direction of the propagation. So Rayleigh wave is very much the same as your water wave. Love wave, on the other hand, is like an S wave. They are transverse wave but with no vertical motion. They are like a wriggling snake, causing the ground to twist side by side, resulting to great damages and destructions to people and the environment. So these are the two types of surface wave. The Rayleigh wave, which is like a water wave, and the other one is the love wave, where in the ground is moved in a side-to-side motion. What about seismographs? So seismographs are instruments that are used to detect earthquake and record earthquake. So how is the earthquake's epicenter located? So earthquake's epicenter can be located by the behavior of the seismic waves. So in that case, P waves will arrive first, followed by the S waves, then the love and Rayleigh wave. Average speeds for all these waves is known. After an earthquake, the difference in the arrival time at a seismograph station can be used to calculate the distance from the seismograph to the epicenter. So as you can see here, the first wave to be detected by the seismograph is your P wave. Okay? So in a seismogram, which is a record of your earthquake, you can see here the arrival of P wave. And then after the arrival of P wave, it will be followed by the arrival of S wave. The time between the arrival of P and S wave can be computed by subtracting the time of the arrival of S wave to the arrival of P wave. So in that case, we can be able to compute the PS time interval. So again, to compute for the PS time interval, arrival time of S wave. So we have the arrival time of S wave minus the arrival time of P wave will give you the time interval. Okay. Following your S wave, the seismograph will detect the arrival of love wave. What we have here is the time distance graph showing the average travel times for P and S waves. So the farther away a seismograph is from the focus of an earthquake, the longer the interval between the arrivals of P and S wave. So for example, we'll choose 5 minutes rather. So in 5 minutes, so at this particular station, P wave was detected after 5 minutes. And then, followed by the S wave. So S wave is here for this station. So let's say it's approximately 9 minutes. Okay. So to determine the difference between the arrival times of P and S wave, we just need to subtract 9 minutes minus 5 minutes. So we will get the interval be equal to 4 minutes. And that is for this particular station. As for this seismographic station, let us compute for the time interval. So let's say this is the arrival of P wave. So it's in the middle of 10 and 15. So it's approximately 12.5 minutes. And then your S wave is approximately equal to 23. Let's say it's 23 minutes. Okay. So to get the time interval, it will be 23 minus 12.5. So you will get 10.5 minutes. So the time interval for this seismic station is 10.5 minutes. So based on the graph, if a seismographic station is far from the epicenter, it will have a greater time interval as compared to the one closer to the epicenter, wherein you will have a lesser time interval. Now, how is earthquake's epicenter located? 3 seismograph stations are needed to locate the epicenter of an earthquake. A circle where the radius equals the distance to the epicenter is drawn. The intersection of the circles locates the epicenter. So for example, we have here one seismographic station or seismograph station or seismic recording station. So at this point, we have detected an earthquake that is of a certain distance. Okay. So we'll draw a circle. So anywhere in the circle could have been the epicenter of the earthquake. And we'll draw another circle in the from the second seismographic station. So in this case, we have Rio de Janeiro for the second station, and the earthquake is detected at some distance from Rio de Janeiro. So we'll draw a circle. So anywhere in the circle could have been the epicenter of the earthquake. But in this case, we can see that there are already intersections. So at the intersections, the intersection could have been the epicenter of your earthquake. However, based on this diagram, we can see that there are 2 intersections. Therefore, we have 2 possible epicenters. So for us to determine exactly where the epicenter is, we need to draw the last circle. Okay, so at this time, we have a station in Berkeley. And then, we need to draw a circle again. Okay. And here we can detect, okay, the intersection of the 3 circles, which is actually the epicenter of the earthquake. So that is how you locate an epicenter of earthquake. Okay. So if we have A, B, or C, the correct answer will be C. So that is what we call a triangulation. So in triangulation method, we identify at least 3 recording stations, compute the distance of the epicenter from the stations using the time difference in arrival of P and S wave, draw circles around each station using the computed distance as the radius, and the point of intersection of the 3 circles determine the epicenter of the earthquake. For your activities in the module, you have the following task to do. So first, you need to name the type of seismic wave shown below. So in this case, you have 6 choices, right? So you have a body wave, surface waves, and the types of these seismic waves, you have P waves or S waves. And for the surface waves, we have love waves and relay waves. So these are your choices for this particular part of the activity. Next, for activity 2, watch the difference. So basically, you just need to compute for the difference in the time interval of the difference between the arrival times of P and S waves. You are asked to express your answer in minutes, second, but I'll be accepting answers in seconds as well. So just to give you an example, for seismic recording station S, A, so SRS A, okay, seismic recording station A, we have the arrival of P wave. So arrival of P wave is at 23 minutes 20 seconds. Okay, while the S wave arrives, okay, 27 minutes 40 seconds. Okay. So what you can do here is to convert first the 23 minutes into seconds. So you will have 23 minutes. So convert it into seconds. You'll have, for every 1 minute, we have 60 seconds. So computing for this one, we'll just have to multiply 23 with 60. So 23 times 60 is 1,380 seconds. But this is just for 23 minutes, so we still need to include 20 seconds. So plus 20, so the 20 is coming from here, so that would be 1,400 seconds. The arrival of S wave, so we'll just do the same, 27 minutes, then 60 seconds for every 1 minute, cancel. So 60 times 27, so that's just 60 times 27, you will get 1,620 seconds plus the 40 seconds here. So you will get 1,660 seconds. Okay? And to get the difference in the arrival time of P and S wave, you just need to subtract the arrival of P wave, S wave, rather, minus the P wave arrival time. So you will get 260 seconds. And to convert that one into minute second, you just need to divide 260 divided by 60. So you'll get 4. That would be 240, and then remaining of 20. So you will have 4 minutes 20 seconds. So this 260 seconds is equal to 4 minutes 20 seconds. Okay? So this is your answer for seismic recording station. So just need to follow these steps to get the time difference of arrival times of P and S waves for seismic recording station B, C, D, E, and F. Following this one, we have far away from you. So in far away from you, you just need to compute for the distance from the seismic recording station to earthquake epicenter. So for you to compute this station A, sorry, with that one. So this 6 minutes. So the distance from station A is 4,500 kilometers. So you just need to do the same for the other stations. And following this one, we'll take you farther. So in this case, other than computing for the distance, we need to compute for the scale, okay, of the epicenter from the seismic recording station. So the direction for activity 4 is to determine the distance in kilometer from the seismic recording station to the epicenter using the equation and distance in centimeter cm. Use the scale below as a reference. So D is equal to TD divided by 8 seconds times 100 kilometers. And for every 100 kilometers, we'll have a scale of 1 centimeter. So, as an example, we'll be computing the distance of the earthquake epicenter from a seismic recording station in Batangas, and to convert the distance into its scale, that for every 1 centimeter, it's equal to 100 kilometers. So for Batangas, we have 9.6, so that would be 9.6 seconds divided by 8 seconds times 100 kilometers. So you will get, so that is 9.6 cancel for the second. 9.6 divided by 8, you will get 1.2 times 100 kilometers. So that will be 120 kilometers. So this is now your distance from the earthquake epicenter. And to get the scale, you just need to follow the scale. So for every 100 kilometer, you have 1 centimeter. So number is cancelled. So 120 times 1 is still 120 divided by 100, 1.2 centimeters. So in your map, the distance between Batangas and the epicenter is about 1.2 centimeters. Okay, so you just need to compute for San Fernando and Tuguegarao. Doing this one, we have locating the epicenter. So I'll just give you an idea on how to do this one. So according to this one, Batangas is 1.2 centimeters away from the epicenter based on this particular map. So if you have this distance, so you just need to measure 1.2 cm. Okay, so this is Batangas. So we just need to measure 1.2 cm. So let's say that's 1.2. And then we are not sure if the epicenter is at that particular position or could have been at the north or east, south, or west. So we draw a circle. After drawing a circle, we will proceed to the next station. So we have San Fernando. So in San Fernando, the distance from the epicenter is about 2.6 centimeters. So again, you just need to measure 2.6 centimeters from using your ruler. And then after that one, we are not sure if this particular epicenter is from the north, south, east, or west, or northeast. So we need to draw a circle again. Okay, so now we have 2 circles. Okay, so the last one is to draw the third circle from Tuguegarao. So from Tuguegarao, the distance is about 3.8. So just measure 3.8 centimeters using your ruler. And using your compass, you need to draw a circle with that particular radius. Okay, so now we have 3 circles, and based on the 3 circles, where is the intersection? The intersection of the 3 circles will be the epicenter of the earthquake.